ළමයි. Okay, girls, now listen. Let's take our paper. Okay. Paper one. Paper one. Online students, I hope you have the paper with you. Right. Now in this paper we have 2025 level questions. Questions that you can do up to now. Okay, so up to inorganic, I included the questions. We'll start from this first structured essay and let's see how much we can get from this. Because we noticed in our previous papers that we all have few things to improve. And to improve those things, let's do this discussion by taking some time. Right? What about the first question? Now, yeah, we have 6 sub questions in the part A. What about this first part? So you need to see state whether these statements are true or false. Okay, take the first one. The pairing of electrons. That one. The pairing of electrons in a particular subshell does not take place until all the orbitals of the subshell are singly occupied by electrons with parallel spin. What is this theory? Answer rule. Very good. Okay. So when we write electronic configuration, we need the 3 principles. Okay. To write the configuration, actually we need 2. So what are those 2? Pauli's exclusion principle and Aufbau principle. From those 2 principles, we can write the electronic configurations. Let's say oxygen. Oxygen electronic configuration is 1s2, 2s2, 2p4. So we know how to write this one according to those 2 principles. What is the first one? Pauli's exclusion principle. Okay. In Pauli's exclusion principle, what it is telling Lama? In an orbital, you can keep maximum of 2 electrons. You can keep maximum of 2 electrons. Let's say 1s you have 1 orbital. So in that orbital, you can keep maximum of 2. That's what it is telling. Okay, like that. Then 2s you have maximum of 2 electrons. Like that, you can keep maximum 2. Then the next principle is Aufbau principle. In Aufbau principle, what it is telling? They are telling the filling order, in which order we should fill. Okay, so first we are filling 1s, then we are filling 2s. Like that, energy, electrons are filled in ascending order of their energy. So 1s, 2s, then 2p, 3s. After 3p, 3s, you have 3p. After 3p, you have 4s. After that, 3d. Like that, remember that order is given by what? Aufbau principle. Okay, so by following those 2, you can write this electronic configuration. But the theory stated in the first question is needed when we are drawing the orbital diagrams. Now let's say I want to draw the orbital diagram of this one. Orbital diagram of this one, the P4. Then I need that other principle that she mentioned. What is that? Hund's principle. Hund's principle. So Hund's principle is needed. Hund's principle is telling how P4, P3, P2, P5, P6, anything, how they are going to be filled. Okay. So in P sub energy level, you have 3 orbitals. According to Hund's principle, it is telling when you are filling P4, First of all, they are filled one per each orbital, single, in other words. Then it become pair. Okay, so according to Hund's principle, we can draw orbital diagrams. Understand? So to write electron configuration in this way, we don't need the Hund's principle. Hund's principle is needed for representing orbital diagram. Simply, what is orbital diagram? It is showing you how many electrons are there in each orbital. Orbital diagram. Understand? This is also an orbital diagram I put earlier on there. But here we don't have any problem because we have only one orbital. But when we have several orbitals in a sub-energy level like 2p, 3d, then we need this Hund's principle to draw them. Understand? So by getting this, what is the importance of this diagram? What we can get from this diagram? We can know how many unpaired electrons are there. Okay, so how many unpaired electrons are there? 2. So like that, they can ask further questions on this. Is that clear? Electronic configuration is not a bad thing that you all can do. And it's important to know what are the other theories that can, other questions that they can ask associating this. Okay, first thing is what? Pauli's exclusion principle, then Aufbau principle. Those two are needed to write the electronic configuration. And the next thing is orbital diagram. To draw the orbital diagram, we need Hund's principle. That's it. Is that clear? Hmm? So, a very short review for this one. Okay, and let's keep our reviews separately for these papers, Lamai. Now you are having three things. Monthly based reviews are there. Then you have these reviews, and then you have a theory note. There are three things. There are images. Right. Right. So what's this statement? Is it true then? Forward to us. Yeah, it is true. Then. First one is telling about the Hund's principle. So like that, when we are, let's say, in a shadow question, I can ask you about the Aufbau principle. I can tell you that. I can ask you that whether the electrons are filled in ascending order of energy. That's correct. This is the ascending order of energy. And this is also telling you an important thing. You remember, OS is filled before 3D. That's also a good statement. Okay? Now, energy levels are not fully completed. Now, before completing third energy level, there are electrons filling to fourth energy level. That's also very important. Okay, just listen to what I'm telling and write down what is important for you. Okay, online students, you understand this one well? Here, electrons are filling ascending order of energy of form. Energy of form. So this is also important. Force is filled before 3. Now, Pauli's exclusion principle is telling what? Maximum number of electrons in an orbital is 2. You can't fill more than 2 electrons. Pauli's exclusion principle. These theories are asked Lamai. Now, I remember in one paper, there was a statement, 11th paper, there was a statement. Pauli's exclusion principle eliminate the possibility of having a third electron in an orbit. Pauli's exclusion principle eliminates the possibility of having a third electron in an orbital. That's correct, isn't it? Now, according to that, maximum is 2. Like that, these three theories, same theories, they are asking them in different ways. Maybe in an MCQ, maybe in a structured essay question like this. So get that practice. Get that practice. Right. What about the second one? That is from quantum numbers. That is from quantum numbers. Okay. So there are three quantum sets given. Actually, the first two quantum numbers n and l values are given. Okay, n and l values are given. First one is n equal 4, l equal 1. Second one, n equal 4, l equal 0. Third one, n equal 3, l equal 2. This is a common question. Okay, and it's asking the increasing order of energy. So where it is focusing about this rule of Bow principle. Right, so of Bow principle is showing you 1s, 2s like that. So how this 4, 0, 4, 1 is connected to that? Can you explain? Fourth, fourth energy level is so N represents the energy level. And in these electrons are there in fourth energy level, and third energy level. So N represents energy level. Okay. What is the name of N? Principal quantum number. And then what is this L? L is the next quantum number. We call it as azimuthal quantum number. Okay, azimuthal quantum number. It is representing what? Yeah, the sub-energy level, or you can say the shape of the orbital. Now you said S. S is a spherical shape orbital. So like that. Then this one is one stands for p orbitals, dumbbell shape p orbitals. Like that. It is telling you which type of an orbital you are filling electrons. Understood? Okay. So simply you can tell if it is 4 1, then it must be what? 4p. And this one 4 S, and this one 3D. Okay, so if someone has forgotten this L value, just try to remember. L values can be 0, 1, 2, 3 like that. So then each represent the shape of an orbit. Shape of orbit. If it is a 0, then S orbit, P orbit, D orbit, F orbit, like that. They have their own shapes. For example, S orbital is a spherical shape orbit. P orbital is a dumbbell shape orbit. Understand? Dumbbell shape orbit. Right. So remember that. Okay. 4 0. Right. So then what are the other quantum numbers, Laman? Let's try to revise that part first. What are the other quantum numbers we have? ML and MS. What is ML? Magnetic quantum number. MS, spin quantum number. What is represented by ML? Magnetic quantum number. Orientation of orbitals. Now, this is telling the shape of the orbital. Try to write a short note on that. I can see your faces for that. Only write a small review. We don't need to do it again some other time. It's okay. Don't think. Now, what is this representing? The orientation of orbitals. Orientation of orbitals. Now, in the sub-energy level, there is no such orientation. It's just a sphere. There is no orientation for that. Let's say this ml value. So we give the number 0. And for p, there are 3 p orbitals. They are perpendicular to each other. For their orientations, then we give numbers -1, 0, plus. Okay. And then d, you have how many orbitals? We have 5 orbitals, so 5 orientations. For them, we have -1, so -2, -1, 0, +1, and +2 numbers. Right? So that is giving you the orientation of orbitals. And what is the final one telling you? MS spin. So in one orbital, you remember, you can put 2 electrons. One is spinning clockwise, other one is spinning counterclockwise. What is spin means? Rotating around the own axis, spin clockwise and counterclockwise. Right. So what is the question asking? Yeah. If you place them in the ascending order of energy, Okay, you can see now here we don't have 4p here, but after 3D, 4p is fit. Okay, so 4p is the highest one. Then you have 4s. So then you have 3D. Then you have 4s. So ascending order of energy will be 4s, 3D, then 4p. That means Lamai, second one. Then you have third one. Highest energy is there for the first one. So is that order correct? False, ne? So they have changed these two. That's a common question point. That's why I circle this one even before discussing the second question. Because that's a very common thing to ask. Ne? First of all, what we should try to cover the common things. But even a product time, if you can do those theories, obviously, with the practice, you can do that other rarely asked questions also. Right, online students? Hope you understand this one. Any doubt? Second one. So write a good review line. So okay, these are first paper. Moderate reviews lian. Write a good review. Doesn't matter whether it is long. Lian. Okay. Then with the future papers, you don't need to write that much. Giving a short explanation will be enough. But now give a full explanation. That's better. Now think whether you remember these things. Ne? Quantum numbers. There are 4. N, L, M, L, M. It's done only. What we should do is that polishing. Polish karagana. Right, what about the next question? Third one. The electron pair geometry of, now we are shifting the topic to bonding. The electron pair geometry of SOF2, SOF4, SOF4. Electron pair geometry of SOF4. SOF4. Electron pair geometry of SOF4. They are telling it square pyramidal. Should we draw anything? Is it correct? Those who say it is correct, with a square pyramidal. False. Why? What is the reason? Electron pair geometry. Is there any electron pair geometry called square pyramid? No. So no need to draw it. Isn't it? What are the electron pair geometries we have? EPDs. We have linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. These are the 5 electron pair geometries we have. Okay, so square pyramidal, pyramidal is not one of them. Okay, so very easy to say this is false. Now don't waste time by drawing it. That's the important thing in the exam. You need to manage time. Right? First of all, check whether it is an electron pair geometry. If it is not, then okay, anywhere wrong. Right, then let's now this is kind of a discussion. Now let's discuss about that thing. The star pyramid. So where you find this star pyramid? It is a shape. Where you find it? Under octahedral electron pair geometry. For octahedral electron pair geometry, you have 6 repulsion units. 4 are there in the plane, and other 2 are perpendicular to that. When you have one lone pair, that lone pair comes to this place. Okay, and this is our other repulsion unit. Then when you connect them, you'll get a pyramid. Get a pyramid, square pyramid. Okay. So then when you have another lone pair, that lone pair will come to the perpendicular plane. When you connect them, you will see a square plane. So like that. So remember where these names comes. And yeah, it is wrong. Anyway, it is what? Square. Sorry, square pyramidal is a shape, not a geometry. Then what about SOF4? Can you draw it quickly? Try the banana. Whether you can draw it quickly. SOF2. Now for our review, we can put them. Octahedral is octahedral. And here we have one lone pair and five bond pairs. Then it is square pyramid. When you have two lone pairs and four bond pairs, then it is square plane. Try to remember that part only. Now, what about this SOF4? What is the molecule? SOF4. SOF4. Yeah, SOF4. And then you go to the basics now. Get the skeleton first of all. Take the skeleton. And then take the total electrons, 6 electrons from sulfur, 6 electrons from oxygen, and again another 0.4 fluorine atoms, so 4 into 7, 28, 20 plus 12, 40 electrons. From that 40, subtract 10, because we have already represented 5 bonds, and then we have 30 electrons. Then we divide that 30 electrons by 2 and make them into pairs. So we have 15 electron pairs. So once you distributed those paper each atom, all will be finished and there's nothing on sulfur. And now you can check the charges, negative and positive. Now to cancel that charge, what we should do? We have to make a double bond. Okay, then our structure will be something like this. So what's the electron pair geometry of this one? What is the electron pair geometry? What is this? Regular bipyramidal shape and geometry. Understood? So anyway, we don't need that structure to say that the statement is wrong. You have the paper. So explain everything. Now let's say you find these geometries and shapes are kind of 50% of it. So what we should do? Can take your tube and prefer that. What is what are the other things? Now you can study about tetrahedral with examples, with some questions. Spend that time, it works. Trying to complete something at least. Because you have time, your exam is starting next month. I don't know how all anyway, still you manage the time, you pay proper attention. Never, still you can do. You started day levels by having some dream, then one time. You must have some dream. You have current form. We have some difficult situations in the mind, but not in the put that way. This was a long lesson. There are many things to remember. Then on the other hand, we have energy and gases. So also a physical chemistry lesson. Need to do more questions. However, there is pending once we do questions. Okay, right. Let's go to the fourth one. Second ionization energy of lithium is less than that of beryllium. Those who say this is correct, lithium second ionization energy is less than beryllium. Emily. Those who say false, why? You think about the first ionization, that's all. Those who but this as correct. They are thinking about the first ionization. Second ionization. Lithium, you are removing another electron from lithium plus. Huh? So you write something at the bottom. So this is false. Okay, this is false. Right. Right. Okay, now listen. This is lithium's first ionization. I1. And in second ionization, what do? We remove another electron. I2. And now you have to think whether this one is a better configuration or not. Yes, it is a better configuration. Why? Lithium was having 1s2, 2s1, but that s1 is removed here. You have 1s2. 1s2 is a what? Very stable helium configuration. So removing the second electron from lithium will be very difficult relative to beryllium. You understand? But there is an easy way of getting this one in our questions. The diagram, the graph. This one is easy. Now this graph represents first ionization energy, I1. Okay. So then to get the second ionization, you have to come one back. So then lithium second ionization will be it will be similar to helium first ionization energy. And beryllium second ionization energy will be similar to lithium first ionization energy. When you compare the values. Right? Not the equal values, so the values are different. I'm telling you the comparison will be similar to this. Now, okay. We need to know why lithium plus is higher. Say it is a stable configuration. Right now, what are the other periodic properties like this? First ionization, first electron gain, electronegativity, radius, like that. There are several things. Now, when we are doing today's question discussion, we will see few things. And now, I remember this paper we have electronegativity, radius, common theorem. So try to remember this. So you can see in the same graph, ionization energy depends on configuration also. Tell me why beryllium ionization energy is higher than boron. What's the reason? Now, boron is having a lower value than beryllium. Why? Because of this electronic configuration. This is having NS2 stable configuration. So removing electrons is difficult. Beryllium boron. Boron is having 2s2, 2p1. Beryllium is having 2s2. 2s2 is better. Why? Why I'm telling it is better? Because it is a fully completed sub-energy level. NS2 will be emanating, and that one is stable. Okay, just go through them later. Try to understand the answer and the explanation for this particular question. Comment right? Write a good review anyway, but you may have doubts. So go home and study them again. Anyway, by doing like let's say 4 papers like this, the whole syllabus will be covered up to now. Right. For the next question. Electron gain energy of fluorine. Fifth one. Electron gain energy of fluorine is a negative value. Those who say it is correct, negative value. Yes, why? Yeah, because it likes electrons simply. Huh? Okay. So that this statement is correct. Good. Statement number 5. That is true. Alamai, in exam, don't say T only. Right? Remove. You will have no answer. The T and that. Right. So let's explain what is electron gain energy. Is this reaction? F gets an electron. Fluorine gets an electron to become F minus. And now this electronic configuration, now this is likely to have electrons. Because then it becomes stable. Now anyways, this is a better review. Okay. Now boys, don't speak. Trouble for me to teach. Another experiment. It's difficult for me to get the flow. And I get the so I have sometimes that no better. Right now, I1, I1, not I1, EG1. First electron gain, you remember this from energy list or unit 1. EG1 becomes positive. EG1 positive means does not like to have electrons. We have these examples. So remember this one. All group 2 elements. Then all group 18 elements and nitrogen. So these elements are having stable electronic configurations. Stable electronic configurations. Therefore, does not like to accept electrons. Therefore, does not like to accept electrons. Okay. So then you have to think whether fluorine is having such thing. No, fluorine is not having such stable configuration. F. So therefore, it will be likely to accept electrons. Okay, so if it is likely to accept electrons, then the value is negative. Now understand? Is that clear? EG1, first of all, try to remember what is EG1. EG1 can you are getting a gaseous atom and you give one electron and see what happens. Okay, so when you are doing that one, some elements don't like to accept electrons. Group 2, 18, and nitrogen because they all have stable configurations. So they don't like to accept electrons. Okay, so because of that, they are having positive values. Positive values means endotherm. We need to forcefully give electrons. Okay, we should spend energy. But these elements like fluorine and others that are not belong to these 3 types, then those elements like to accept electrons because once they get electrons, they will become stable. So they release energy. So exotherm, negative. Okay, so they can ask the same thing in those words also. Negative, exo, release energy. All are same things now. They can ask the same question again in that right? So that the statement is correct. Right now, go to the statement number 6. Statement number 6. Among the atoms, beryllium, carbon, and silicon, beryllium, carbon, silicon, sulfur. Beryllium, carbon, silicon, sulfur. Among these 4 atoms, atomic radius that order is not given. Okay, give me a second. Let's see what is given in the paper. Lama. Yeah, Budhi. Yeah, come. 2025 MCQ. Okay, anyway, so we'll write the correct order. I can't find it right now. What is the correct order for the statement number 6? Radius. Radius increases in which order element? Beryllium, carbon, silicon, sulfur. Think where these elements are. Beryllium, boron, carbon, silicon, sulfur. Phosphorus, not sulfur. Phosphorus and then sulfur. Alright. So what do you think? Beryllium should be larger than carbon. Then silicon will be larger than. Yeah, silicon will be larger than sulfur. Okay. Silicon is larger than carbon. That's how we had to connect it. Sulfur and carbon. Yeah, but there's a small. Yeah, you can say like that. Now, these are the things you can get. Silicon is larger than sulfur. Then silicon is larger than carbon. And carbon is smaller than beryllium. Now, we have a small problem between these two. Right? So then I think we need to find out that question. Do you have the it is for some noted. What is the order? Carbon, away, carbon, ascending order, carbon, beryllium, sulfur, silicon. Carbon, beryllium, sulfur, silicon. Yeah. Why? Beryllium is smaller than sulfur. Beryllium is smaller than sulfur. No. That is the question itself. True or false? Make a true then hand. Yes. Why it is false? Tell me. Beryllium is larger than sulfur. Beryllium is larger than sulfur. How you can tell? Even common again, beryllium is larger than sulfur. Is it the order given in the Okay. So here's the thing, Lamai. Now about radius, across the period radius decreases. Downward the group radius increases. So this is not a good question. How do we know whether it is beryllium or sulfur? Isn't it? We need the values. Yeah. So mistakes happen. We'll say the highest again. Huh? You remember those values? So I'm asking whether you remember those values. So asking such question is not that fair. Eh? I don't know. We'll ask from that. Follow. Is it true or false? False. So then, according to resource book, but beryllium is beryllium is larger than sulfur. So make all ignore karan. What you need to know, and I something else will happen. Not this again. Okay, what you need to remember is Lamai. Downward the group radius increases. That's what for the silicon and carbon. Downward the group, downward the group radius increases. And then these two across the period, radius decrease. So there are other points associated with this one, mirror, descent, and mirror. There are several other points, but for this question, they are going to ask about this. But the beryllium sulfur thing, we can't say exactly. But anyway, they have given this statement as false. This is not the correct order. Okay, my statement is false. Then what is the correct order? Correct order should be carbon, sulfur, beryllium, and silicon. That's what they expect. But even though they give a question like this, we don't need to. We shouldn't try to remember the values. Say that. Yeah, yes, last year. Yeah. We'll have 99.9 marks. So don't worry. 20. So we have things to worry more about this, more than this. Okay, ඉස්සර complete කරලා ඔන්න තව time තිබ්බොත් just memorize the values. Obviously you don't have any time to worry. And මේම ඒවා දෙනවා sometimes there are mistakes. හරි. In each year something like that will happen. In your year also there will be something very odd in the paper. So study the things about radius that were there in our tube, other than this. So then the next one is about ionic radius. Ionic radius. Ionic radius. Ionic radius of oh, middle bit. A3 plus O2 minus F minus and S2 minus. Right, what about their radii? Ions. Ions. Now about these two, these three are isoelectronic. Okay, what is isoelectronic means? Isoelectronic, same number of electrons. So how many electrons are there here in each ion? You have 10 electrons. Okay. If you have isoelectronic ions, radius is changing in this way. Radius is changing in this way. Sodium, magnesium 2 plus and aluminum radius. Radius is decreasing as the number of protons increase. From this you can understand O2 minus, F minus and aluminum locations. Now the order they have given says S2 minus, F minus, O2 minus and Al3 plus. So now is that correct? No. Because of this part, we can say this is wrong. O2 minus is larger than F minus. So this is the way they should ask in the exam. Not that kind of questions. Okay, that's not fair. Comment that. You already have asked me. Now what should be the correct order? Correct order. S2 minus will be very large because it is having 3 energy levels. And then S2 minus, O2 minus, then you have F minus, and then you have A3. This is the correct order. Right? So now in these 7 questions, what did we remind Lama about? Yeah, periodic properties, electronic configuration, quantum numbers, and then electron pair geometry. Now those theory areas were kind of addressed by these questions. Now see whether you remember those. What is there in the first question, first part? It's about the Hund's principle. The Hund's principle like that. Tell me what is Hund's principle? Look at the Hund's principle again. What is telling in the Hund's principle? Yeah, first same spin, then they pair. Electrons are filled one per each orbital first, then they get paired. That is the Hund's principle. With that Hund's principle, we reminded the other two principles theories also. What are the other two theories now? Pauli's exclusion principle, which tells you maximum two electrons can exist in an orbital. And the other one is Aufbau principle, which tells you orbitals are electrons are filled in ascending order of their energy. Okay, and then we went to the next question. It is about quantum numbers. First two quantum numbers are telling you its energy simply. First quantum number tells you the energy level. Second quantum number tells you the shape of the orbit. Okay, so 40 means what? 4, 4s, 42 can 4d, 32, 3d, 2, 2, 2, 2. 2D now it's a wrong quantum set. 2D tamai, but then you have to say okay, it's 2D, but 2D something is not exist. Like that, they can ask questions about correct, incorrect quantum sets. But like good. And then they ask about the ascending order of those quantum sets. So for that we use Aufbau principle. So what is important regarding Aufbau principle? Of energy levels are not completely filled. First energy level is completed, then second energy level is completed. But before completing third energy level, fourth energy level starts to fill. But that's why in all levels you had that 2881. It was not 289, 2881. Why? Before completing the third energy level, fourth energy level was starting to fill, filling. Right? So that means 4s is filled before 3. The theory point is asked. And then the third question we saw about the electron pair geometry, and it was an easy question. Why? Square pyramidal is not an electron pair geometry. So from that point, we say that is wrong. And then we studied about what is electron pair geometry and what are the 5 electron pair geometries and what is the electron pair geometry of SOF4, like that we studied. SOF4 was having trigonal bipyramidal electron pair geometry. SOF4. You remember we do that. And then the next one is about, all those questions are about periodic properties, second ionization, electron gain, atomic radius, ionic radius. Those are the things that were checked. What about the ionization? Yeah, first ionization, you remove one electron. Second ionization, you remove another electron from that. Okay, so to assess second ionization, what is the method, Lama? We draw that zigzag variation, that is for the first ionization, and to get the second ionization, we come one back. In that case, you can notice lithium plus was having the helium configuration. So removing the second electron from lithium is very difficult. And then the next one was about electron gain energy. Electron gain energy. In electron gain energy, the important thing we need to remember, some elements they like to accept electrons, some don't. Okay, those who like to accept electrons, they don't have stable configuration. And those who are having stable configurations, they don't like to accept electrons, like group 2 elements, group 18 elements, and nitrogen, they have stable configuration. So they don't like to accept the electrons. So fluorine, now the question is given about fluorine. Fluorine is not such element. Fluorine doesn't have any stable configuration. So it would like to accept the electron. When it is accepting the electron, that means it releases energy. So exothermic, negative. Remember that part, endothermic na positive. If it is exothermic, then it is negative, right? And then the next point is about radius. That one I said it's not fair to ask in levels, but you need to know about the about that across the period radius decreases, downward the group width increases, and then you need to remember about that zigzag variation. So mirror descent variation. Remember adjacent 4 elements. Let's say like oxygen, fluorine, sulfur, chlorine, something like that. So how their area is changing? Their area is changing. Sulfur is the largest, then chlorine, then oxygen, then fluorine. Here we know exactly downward the group effect is more powerful than across the period. That's why chlorine was large. In here, we can't predict like that. They are asking whether sulfur or beryllium is large. That's not good. We can't say decide. Okay? So that's why I ask you to remember these points only. And in the next one, it is a good question. What isoelectronic series? Okay, so in display radius decreases. This is the theory point we need to remember. Using that one, we can say that this part is wrong, and this is the correct order. Like that, I review the questions. Then you are studying those same questions again. And you will remember the same things we discussed again. Okama cycles. You have to study this one again and again and again. Right. What about the next part, Lam? About Lewis structure. We'll do that too. Okay, so those who drew the Lewis structure, yeah, what is the problem? Safi. And then I think I sent. Yeah, I sent. Safi, are you there in the meeting? I think she is there. CnSO2. Okay, Lamai. Now, have they given any skeleton? No. Then what we should do? Take the lowest electronegative atom as the central atom and draw the skeleton for ourselves. What is the central atom then? Chlorine or sulfur? Sulfur. Let's say if someone don't know to select whether sulfur or chlorine, then we should say you are in a very bad situation. Then he or she need to remember this order. Remember this one, this is the electronegativity order. Write it somewhere. Electronegativity order. According to this order, you can decide which one is less electronegative. Now you can see that order. Sulfur is there, chlorine is there, oxygen, fluorine, everything is there. Right? So sulfur is the lowest electronegative element. Okay, tell me what to do next. Now, if you follow the proper Lewis method, it will take few minutes to draw this one. Or you can draw it directly without using the Lewis method. Okay, with your practice, you can do this. Right? So now, when sulfur is there as the central atom, normally it will make 6 bonds. And it can. If it is not making 6 bonds, then it will make 4 bonds and keep one lone pair. Those are the possibilities for sulfur. You understand that one? Sulfur, normally it will form 6 bonds. It will form 6 bonds. Or it will keep a lone pair and make 4 bonds. We don't know what will happen, right? But this is the possibility for sulfur. When fluorine is there, it always make this bond, a single bond only. Then when chlorine is there, normally it forms this one. Normally. When oxygen is there as a central peripheral atom, it makes a double bond and with no charge. With no charge. So here you don't have any charge, then you don't have any negative charges. Then it assumes this arrangement. Let's say you have a negative charge. then it will take this arrangement with negative charge. If the molecule is having an overall negative charge, then it will take this arrangement. Okay, now these are the things you gather from the practice. Now try to get the structure using that. So now you have this fluorine, then it must have must make only one bond. And then you have chlorine, again it must make only one bond. And with two fluorine, two oxygen atoms should make double bonds. Now sulfur has completed the 6 bonds also. Now this is the proper structure. Is that clear? Without going to Lewis method, we can do, but for that you need a good practice on it. Now let's say we don't have that much practice. Then what? Then you are going to the Lewis method. One Lewis method. Now listen to this also now. Fluorine gives you 7 electrons. Fluorine gives you another 7 electrons. Sulfur 6 electrons. 2 oxygen gives you 2 into 6, 12 electrons. So altogether we have 32 electrons. From that subtract 8, 24. 24 divided by 2, 12 electron pairs. Then apply those 12 electron pairs starting from peripheral atom. All electronegative atoms all are consumed. Then check the charges. Then check the charges. Here you have negative charges and a +2 charge. Then to cancel the charges, double bond method. Then still you will get the same structure. Don't take the risk if you are not sure. Draw it. Yeah, okay, if you have enough confidence, then directly get this. It's up to you. With practicing somehow before when you are going to the exam, we'll be drawing in this way, Keriman, without the Lewis method. Because you remember we needed a Lewis structure for earlier question also. So if right, online students, is that clear? Need out? Then yeah, one online student has suggested this one. What about that? Double bonds. Let's see this one. Now can we draw like that? No. Now this is a skeleton we are predicting. We can't predict like that. If they are not giving you the skeleton, if they are not giving you the skeleton, we must draw the skeleton in that way. Select the lowest element, electronegative element, lowest electronegative element, and place it at the center. Then put all remaining atoms around them. No matter whether you have 4 atoms or 5 atoms, put all around them. We can't guess skeletons like that. Now let's say honestly, it is a skeleton like that. Then they must give it to us. They will give it to you. They are not giving any skeleton. Follow that order. Right? Right. Now they are asking the oxidation state of sulfur. What is the oxidation state of sulfur? This sulfur plus plus 6 ne. How do we get it? Yeah, the more electronegative atom is chlorine. Here, chlorine. Here, oxygen. So you can see all these bond electrons are partially attracted more towards the more electronegative atoms. So that means sulfur lost 6 electrons partial. Now sulfur was having 6 electrons in its own electrons in. Those electrons are lost partially to other peripheral atoms. That means oxidation number will be plus 6. DNF. That's how you take it now. I want to remind this oxidation number thing. Let's say someone has forgotten this one. What about this one? COCl2. Now this carbon has lost 4 electrons partial. So oxidation number is plus 4. What about this one? NO3 minus. What is the oxidation state of nitrogens? Plus 5. How do we say that one? Here 4 electrons are lost partially. 1 electron is lost totally. So overall 5 electrons are lost. So oxidation number is plus 5. That's how you see it. And you have to consider total losing and partial losing all. Remember that one. If someone wants to write this one, I'll give you an all. Now here you can say lost 1 key total. If you have any slight doubt, if you have any slight doubt, at least write this one. And lost 4 electrons partially. Now altogether it lost 5 electrons, so therefore oxidation number is plus 5. If they are gaining electrons, oxidation number will be negative. Now this fluorine, for example, oxidation number will be minus 1. Minus 1, minus 1, minus 2, minus 2. Like that. The addition of all oxidation numbers will be equal to its charge. Here you don't have any charge, so then the addition will be equal to 0. 0. Sun is chlorine. Next one is about resonance structures. Resonance structure. H N double bond plus O. Okay. So draw 2 more Lewis dot dash structures. Yeah. So how many total Lewis structures you can draw? Including this, only 3, ne? So they are asking the other 2. How do we know that one? Because we are getting the Lewis structures by changing the locations of the 5 bonds. Locations of the 5 bonds. Now here you can have a negative charge. And then there's another structure similar to that one. Okay, now tell me, you think about these 2 structures. These 2 structures are identical. Okay. What about this one now? I'll label it as A and B. But it's more stable, A or B? Why? Right. Now here, can you see the negative charge? One of the negative charges is given to nitrogen. Nitrogen is a less electronegative atom. So that means it doesn't like that much to keep electrons. Now, if you are allocating a negative charge means extra electrons. If you are allocating extra electrons on someone that is not likely to keep electrons or less likely to keep electrons, that is making it not that stable. So having electrons on some element which are more likely to have electrons is better. Okay, so this is stable. And they have already said it in the question also. And these 2 are less stable. Or you can say relative to the first structure, these two are unstable. Understand? The reason is what? Nitrogen. You can say less electronegative. Nitrogen got the negative charge. Less electronegative, nitrogen got the negative charge. Okay, now if you put percentages, let's say this is 60% stable. These two are, sorry, 60%. We write like 20-20. Hello. I need two chairs to see. What in there? What happened? Okay. Tell me in the calculation number what. Now, Laman, what is the meaning of this 60? Tell me. Okay, අනිත් එක බොරුවක් කියන්නේ. What is the meaning of this 60? Yes. Now see, you guys are good today. One ඉස්සරහට ඇවිල්ලා. 62 and what does that mean? Yeah, this structure contributes to the hybrid more than the other structures. This contributes 60%. This is some random number I put on it. And these two structures are equally contributing, but their contribution is low. Okay, so real structure is none of these three. It is a more stable structure than any of these three. But that stable structure is formed by combination of these resonance hybrid. Understand? Okay. So are they asking you to explain whether they are correct, stable or not? Yes, no. So say unstable. Only two structures. So can it be less stable also? Don't think so. Is it given less stable in the marking? Yes. Marking any further? Less stable killer? You don't get any marking. Kalin value. Hydrogen is similar to oxygen. Yeah. It's just a small difference. Telling less stable is also okay. Yeah, same. Can't say, but in the memory, there are only three structures. You can remember for your syllabus, there are only three structures. When you learn further, you learn further. Then you will see there are other structures we can draw, but they are really unstable. This is interval එකේ මම ළඟට එන්න කොලයක් ගන්න මම ඇඳලා දෙනවා. Okay? No need to say it in the class or anything. ඒක තියෙන එකක් නැතිව. It's also එකක් තමයි තියෙන්නේ. Right. Now what about the table? Now let's quickly mark it ළමයි. N1 BSc PR pairs 3 electron pair geometry trigonal planar shape angular open and hybridization is P2. Okay, mark it. N2 2 linear SP. For N3 3 trigonal planar bento angular SP2. Then last one N4 4 tetrahedral again angular bend SP3. Maybe that is your favorite question in the paper. Right, then what about the bonds? Alamai, listen. N1 and F. N1 and F. Yeah. HP2, SP3, or you can say 2P. For fluorine is a peripheral atom. You don't have the paper with you. Lagan. Satte නැතු ඉන්නවා. මේ කොල්ලෝ යන්නේ එක. You have the paper. Yeah. Then, Lamai, fluorine is a peripheral atom. So you can write it like 2p or sp3 also, no problem. N1, N2, sp2, sp, mark it, Lamai. N1, sp2, N2, sp, then N2, sp, next one, N2, N3 bond, sp, sp2, then N3, N4, sp2, sp3, N4H, sp3, 1s, sp3, 1s. Then the 5 bonds, 2p, 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 2p. Again, wherever you see a 5 bond, don't write 2p on it. This is yeah, can. D orbital 5 bond හදන්නේ නේවත් තියෙනවා. I discussed that in some paper classes. You want to remind that to read? Yes. But I think I won't have make it a very not then. So I'll tell you that time. Huh? You are really asking a good question, that's right. Yeah, very realist. Very realist. Now listen. Okay, now look at this sulfur. Others. Look at this sulfur. Now, what is the electron pair geometry around this sulfur? Tetrahedral. So, hybridization is sp3. May separate. Listen. S orbital and all three p orbitals are hybridized to give you 4 equal sp3 orbitals. Okay. Then who wants this 5 one? That's the problem. Right? Normally, 5 bonds are made by p orbital lateral overlapping. How many 5 bonds have? So then how was that 5 bond was formed? That is the issue. Now sulfur doesn't have any more p orbitals to make it because all the p orbitals were participated in hybridization. Then who forms the 5 bond? 5 bond is made by the d orbital. Okay, so this is how it happens. Sulfur electronic configuration is 3s2, 3p4. Can you see that? Sulfur electronic configuration is 3s2, 3p. Three s2, 3p4. That means you have electrons like this. This is paired, sun paired. And now, before undergoing hybridization, it excites one electron for one of the 5 d orbitals. Now, sulfur has d orbitals. It excites one electron to that. Right? And these are undergoing sp3 hybridization. And one orbital will have a pair of electrons and others will have 1 electron per each. So this is the one with that pair electron. And then this d orbital, I'll draw it like a dumbbell number, but it's not the actual shape. That will remain unhybridized. So that d orbital will make the 5 bond. Then come. So that d orbital will make the 5 bond. Is that clear? Girls, now the one who asked the question, that clear? D orbitals. Again, in LL exam, they will not ask whether d orbitals are participating in bonding or not. They will give you something with P. But another thing. Not now let's say same sulfur. Take this SO2, for example. Here, this one is trigonal planar. Regional pair means sp2. Make this listen. sp2. So one p orbital is there. So this is between 2p 2p. And this pi bond is made between, sorry, not 2p, 3p of sulfur. And this one is from 2p and 3d of sulfur. Can you understand that? Clear? Now sulfur is having 3p orbitals. So one pi bond is made by that 3p orbital and the oxygen 2p orbital. 2p is coming from oxygen. And this other pi bond, now sulfur, now this is p2, so only one p orbital was remaining. That orbital make a pi bond with this oxygen. And the other pi bond is made by the 3d orbital. Sulfur is having a 3d orbital for that. Excitation, it will be something like this. Now we'll consider this sulfur. 3s2 3p4. Now it is paired 1 1. And when undergoing excitation, this similar excitation to earlier. Now these three orbitals are making sp2 hybridization. 3 sp2 orbitals. And this one will be there to make 5 bonds. That's what happened. Okay. So remember that one. If yeah, anyway. Online students, hope you understand that one. Right? There any doubt regarding the orbitals and pi bonds, sigma bonds? Now for 2028 batch, next week we are discussing that sigma bond, pi bond hybridization, that theory. You can come or join online if you want. Right, next one. Yeah. Yes. Next one, Lamai. About the approximate bond angles. Approximate bond angles. Tell me, what is the bond angle around N1? This can N1 bond angle. Yeah. Yeah, 117.5. For one lone pair, you have to subtract 2.5 degrees. 117.5. N2, what is the bond angle? 180. N3, again 117.5. 118 is also okay only. Yeah, if you have written. Then N4, 104.5. For one lone pair, always remember, let's subtract 2.5 degrees or 2 degrees. Then when you have double bonds or triple bonds, you don't subtract like that. That doesn't mean double bonds and triple bonds are affecting the angle. And that doesn't mean they are not affecting the angle. They are affecting the angle, but that effect we kind of neglect. We only decrease the angle when we have lone pairs. Double bond we are not going to subtract it. Okay, that's why it is 180 point N2. And what about the electronegativity? So all elements here are nitrogen. The labeled elements are nitrogen. Let me get the structure to the board line. N1. Then N2. Girls, stop talking. Because they not take. Are you fighting? with each other. එකපාර එකක් දෙන්න ඩොං ගාලා ඉවරයි. One shot. Explain the electronegativity. What is the lowest electronegative one? By the problem. And now listen to this. So when you assess electronegativity of atoms of same element, there is an order we need to follow. Score. This is score. X percentage, charge, then oxidation number, then peripheral atom electronegativity. Peripheral atom electronegativity. So let's say if S percentage is higher, charge is higher, oxidation number is higher, peripheral atom electronegativity is higher, then the central atom, the atom we consider, that atom's electronegativity will be also higher. That's the way we compare that. Now, okay, understand? Now all are nitrogen atoms. So now let's start the discussion by getting their hybridizations and S character. Now the hybridizations are, this one is sp2. We said that earlier. So that means Lamai, 1/3 is S now. So there are 3 orbitals in the hybridization, one S and 2p. So from those 3 orbitals, one is S. So what is the S percentage? 33.3%. Now apply the same logic for this one. This is sp3. So 1/4 is S. That means 25% S character. Okay, so what about the other remaining percentage? Other 75. That is P character. P. Now here the S percentage is like 33.3. Then this one. Yeah, let's compare. Like this one is 50% S character. This is again 33.3% S character. This is 25% S character. Now the one with the highest S character is N2. So N2 is the one with the highest electronegativity. Lowest S character is there for N4. Then N4 is the least electronegativity. Okay. Now we can't compare N1 and N3. For that, we need to go to the next point. What is the next point? Charge. So do you see any charges on N3 and N1? So no. Then we can't compare by that charge also. Next point is oxidation now. Okay, now you are listening to the oxidation number explanation earlier. What is the oxidation number of N1? N1 plus 1. Nitrogen, we don't consider any arrow or dipole moment because they are the same atom, same element. So fluorine is partially gaining 1 electron from nitrogen. So nitrogen is losing 1. So oxidation number is plus 1. What about N3? What about N3? N3? 0. No. What? No losing or no gaining because all are surrounded by nitrogen. Now the one with high oxidation number N1 is the one with higher electronegativity. Is that clear? How many of you got this order correctly? Now others, you understood the way? Any doubts? Today we have both Manas. Manas, you understood this one? Did you try this earlier? And now can you understand? Keep doing questions on it. What about this? Fine. Right, next one. Part C. Okay, now I listen part C. First one. Now, what do you know about successive ionization energy? What is successive ionization energy? Yeah, you remove electrons one by one. Take element and you remove its electrons one by one. So we have first ionization, second, third, fourth, like that. You can keep going. And normally ionization energy, the successive ionization energy increases. Sometimes it increases more than we think. Why? Because we are trying to remove electron from a stable energy level. So now let's take this element and see. 1012, 1900, 2900, 4900, 6200. Then we have Lamai 22,000 something. That means these are gradually increasing. But the next element, next ionization is very high. Okay, so that means what? These 5 electrons are removed easily. That means these are the outer electrons, no? So how many electrons are there in the outer energy level? 5. 5 electrons in the outer energy level. So then it should be belong to the group 15. Okay. Because 5 electrons in valence shell. 5 electrons in valence shell. So then it belongs to the group 15. Okay, when you try to remove electrons from a stable energy level, then it has become very difficult. Remember this part now? So as the question they ask me, what is the element? How do we know the element? They says it is in the third period. So third period group 15 element is phosphorus. 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 How many of you got phosphorus? Yeah. Online students, how many of you got phosphorus? Can I see your hands? Good. Successive ionization energy. Draw the graph and explain. Draw the graph and explain. These 5 are easily removed, and this one must be kind of difficult to remove. 5 electrons in the outer energy level. So when they ask for the electronic configuration, give the full configuration of nitrogen. PS2 3p3. Now how that 3p3 is spelled, Laman? According to Hunt's principle, one per each. Can you see now? Kind of even in the same question, we are seeing the same thing again. So doing questions is very important. Now look at the second part of that question. So at the second part, the molecule of formula AX5 has 5 AX sigma bonds. AX5 you have 5 sigma bonds. Here A and X represent symbols of elements and A is the central atom. Table given below. Complete the table given below by naming the possible molecular shapes and giving an example. So if AX5 is polar, if AX5 is non-polar, good question. But the similar questions were there in earlier past papers. Now the thing is we haven't done that much past papers. You don't have that much experience about what are the previous similar questions. But now let's start from this and see. So what is this AX5? That means 5 sigma bonds. At least you have 5 repulsion units. Now you have only trigonal bipyramidal and octahedral for that. Isn't it? If it is trigonal bipyramid, all these X sigma bonds will be arranged like this. And now tell me, is it polar or non-polar? It will be non-polar. It will be non-polar because all dipole moments will be cancelled. And trigonal bipyramidal, this one is non-polar. Now, if we want to become polar, what the arrangement is going to take? It will take that the previously discussed, but square pyramidal arrangement. There will be a lone pair. Then it is polar. This is square pyramid. Square pyramid. Now understand. So this is polar. Square pyramid. Now we need examples also. We need examples also. What are the examples? For this one, you can say PCl5, a good example. Or you can say SF4 plus, SF5 plus. Those are also good. For this one, what is the example? Square pyramid. IF5, DRF5. Or you can say XCOF4. What that? In the practice you will get at the back. Try to think in this order now. When you have 5 sigma bonds, okay, there is a possibility for being in polar and non-polar. Online students, is that clear to you? That's the end of our structured essay question. Okay, so what should you do now? When we are discussing questions now, then I'll be checking the review next day. Now you need to complete April test review. April test again full paper year. So complete that paper. Okay, so I need that review next week. Okay, now you are starting another project. This is another project. Okay, physical papers. Now that one need to be written separate. With the paper, you have to keep. So test papers in one. Set of explanations. Take a book, or finish a file or something. Keep it separately, clean, nice way. And for this paper discussion, you have to keep a separate written. So why I'm asking you to keep them like that? Because then you can study them properly. Okay, you have 10 20 papers and 10 20 explanations. You don't know even the question number. The question number what? So some will contain the question number and you don't know which paper it is. There's no point of writing anything there. So keep them attached. Take a small step low something, take here. And make sure you go through that again also. So give it some time, hopefully time give it some time and do. Things will be getting okay. Till when here. Just the marks are that much good. So I'm telling. Right. So Lama, another thing. What about our power up class? When shall we do that? Next week morning down the Nathan weekend again weekend I can do online. Right about online power up there. So they are online class. You also don't like online. The Friday morning online is boring. I'm telling you, it's okay for you. But I'm not going to think it's not going to do me. Mister, you know, it's not going to. Thursday morning mà tao hay đang mang ra thì có YouTube cắm này nè tao cài para punya itu kemudian I think next week will be a holiday the school will be closed right oh di kampung dia that class in the school weekly betul mana lah bisa dia kan ini kita sekali terus tuh aku kira-kira dia tuh apa tapi I mean, are you going to schools now? Yeah, still. 80% there. You may have 120% or something. Sekarang you're not in school. Okay, I'll think about that. Physical කරන්න තමයි මට ඕනේ. Majority of you are coming, then we will do. Right, now shall we go to our theory discussion?